everyone. So today we're going to be covering dot plots and skewed data graphs. Wasn't quite sure if to put skewed data, but you'll see by the end of the video what I meant. So the objectives today is to cover both of those. So I guess I don't need this after all. Okay, so dot plots are really easy. After like 2 seconds, you're going to be an expert at them. So let's just start with some data, okay? Random data. Let's call this person Joe. And let's say their test scores were 10, 8, 5, 5, 10, 9, 0, 1, 3, I don't know, 3, 10, 0, 1, 1, 1. Okay, there's just some data here. Now, what a dot plot is we're going to take this information here and we're going to put it basically on a number line. Okay? So, your number line needs to cover the spectrum of the data that you have. So what I mean by that is, what's my lowest number? 0. What's my highest number? 10. So we got to make sure that our graph covers at least from 0 to 10. So let's do that. 0, 1, 2, 3, 6, 7, 8, 10. Okay, we have all of our points here. I'm going to move this right there. Okay, so now what we have to do is we're going to take the data and we're going to put it on the graph. 10. There's 10. We don't need that anymore. 8. 5. 5. 10. 9. 0. 1. 3. 3. 10. 0. 1, 1, 1. 1, 1, 1. Okay. And that's a dot plot. Done. Okay. So, I'm going to move on to just a quick explanation. We just took our data here and we plotted it on the corresponding number. So 10 to 10, multiple 10s, multiple x's, 5s to 5s, and so on, okay? The next thing we wanted to cover is skewed data. Okay. So I'm going to separate this. Skewed. And we had a couple of different vocabulary words for this. See how many you can remember. I'm sorry, I should have put data distribution. I'll change that right now. That's what this is. Data distribution. Okay. Okay, so let's say we have our number line here. And let's say we have most of our data coming up this way. Couple here, here. Okay, you get the idea. Now, if we were to draw a curve with it, yikes, a little shaky right there. Try again. Oh, still shaky. So this data here would be considered symmetric. And I can't spell symmetric. Okay, now why is it symmetric? Because if you were to draw a line, straight line, right down the middle, this side here would be the, I'm sorry, just whatever, this side here is similar to this side here. They're like the same thing. So that being said, it's symmetric. It's like a mirror, okay? The other kind of data is skewed right. Now going back to our data here. These are done in no particular order, okay? I'm just putting them in there. Now let's say our data looks something like this. If we were to draw that curve again, like we did here, the red one, it would look like this. Right? Something along those lines. And this is skewed right. Now, here, first thing I thought when I saw this was, why wouldn't it be skewed left or something? Because it's on the left side. But that's just not the way it works. So I think what will help you is think of a tail. Instead of skewed right, you could think skewed tail, because the tail right here. If this were like a dinosaur or something, whatever, dinosaur, that would be the tail right there. So when you see data like this and you draw the curve over it, that's data that's skewed right. Or again, think of it as skewed tail. Skewed right tail. That's even better. Because the tail's on the right. And I'm sure you can guess what's next. Whoa. Skewed left. Oh, screensaver. Okay. Draw this curve. And like before, draw our little dino friend. And this will be skewed right. Right? Skewed. Oh, I'm sorry. I'm messing up today. I apologize, everyone. It's really early in the morning. No one corrected me. Okay. Skewed left tail. Because again, the tail to this buddy dinosaur here is on the left. Skewed left tail. That's it. Symmetric, skewed right, skewed left. Okay? And we have our dot plot. Sorry for all the mistakes. I hope this was helpful.